Gabe. I'm an engineer on TBD focused on standards work and implementation of those standards. And I'll be talking today about a new DID method that we've been working on, myself and Daniel mostly, based on the mainline DHT, which is used in BitTorrent. So first I want to say why a new DID method. There are lots of them out there. This is true. We've been running into some usability issues with Ion, our previous DID method of choice, mostly due to its needing to anchor to Bitcoin. It could take 10 minutes to get a source of truth, which can be tough in some circumstances. And the use of long-form DIDs is pretty awkward. Something silly like pasting it into a chat app might make it get truncated, which isn't great for usability. But we really wanted a DID method that had a lot of properties we care about, like having updates, service endpoints, the ability to have types, and be fairly decentralized. And we didn't really see a good option out there that wasn't tied to a blockchain or existed in another state. So we're introducing this new DID method called DHT, and to give you some background, I mentioned mainline DHT. It's what the BitTorrent network has used for 15 years. It has millions of nodes actively. The estimates range from like 16 to over 20 million nodes at a given time. It's mostly used for announcing torrents and where they exist, but torrents don't necessarily mean illegal or pirated content. BitTorrent is used by many large companies for distributing software. A lot of Linux distributions are distributed over BitTorrent. Microsoft even delivers some updates to Windows using BitTorrent. So it's used throughout the world by many large companies for legitimate reasons as well. And the DHT, it stands for Distributed Hash Table. It's a way to ephemerally share some information. And the information you share can be of any form as long as it's under a certain size limit. And the size limit that we're constrained with is about 1,000 bytes, okay? So that gives us some constraints we need to work with when we were designing this method. Luckily, there's been a member of the community that we've worked with who's worked on this project called Picard. I'll put a link in the channel here. And what he did was leverage the DHT to store any record that you wanted to that was under 1,000 bytes and add some semantic layer to it. He didn't really care about DIDs, so we made an extension to his project to add DIDs. But to talk a little bit more about Picard, the extension it's using on BitTorrent mainline is called BEP44. I'll also add a link to that. And BEP44 pretty much says you could have signed records. So if you have a key, it only supports an 825519 public key, which is good and we like. You could continue to update records over time. And we're leveraging this to say, all right, you have a key, you can update your DHT record. Yeah, sorry, I'll increase the size here. So he has a little demo site, which you might want to play around with. It's pretty neat. You could use this to store directly to the DHT today. So I'll say name. I'll say hello TBD, and you'll see it's showing that it's under that 1,000 byte limit, which is great. We could publish it, which will broadcast it to its 8 closest peers. And we'll be able to resolve this as soon as it publishes. So now this is going to go ask the DHT what the records are. There may be a problem with his UI here, but it did get resolved. Maybe I'll erase that from. Anyway, the important thing is this is a generic way to write arbitrary data to the DHT, and when Daniel and I were talking, we were like, oh, we should make a did method out of this. It's already distributed. It has 15 years, millions of nodes, and can possibly be a good replacement. So the did method, what it does is it leverages the DHT and Picard to define a format using DNS packets to map a did document to DNS packets and then store that in the DHT directly. And this is used for efficiency purposes. So a lot of the spec goes into how that mapping works and how you can represent different key types in the document. To your question, how long does it take to get the data to the entire network? So you broadcast it to your 8 closest nodes, and it takes about 10 seconds. But then when you're querying, you can query any node, and the way a distributed hash table works is pretty neat. If the node, it's kind of like how a DNS server works. If you don't have the answer yourself, you'll ask your peers if they have the answer. And this goes on until you find an answer or don't find one with a certain timeout. So resolution can take about 10 seconds as well. And you'll notice that publishing to our nodes takes about 10 seconds before you're able to resolve it. So that's kind of a high-level overview of the method. We have some additional features of it. One of them is called gateways. Since you could just rely on these mainline DHT nodes that are already out there, the 15 to 20 million I mentioned. But what we're doing is spinning up our own nodes, and our nodes are going to be a little more special in that they'll know about DIDs and they'll retain your documents for you. And they'll also handle republishing. Because it's an ephemeral network, records only have a real guarantee of staying around on the DHT for about 2 hours before they need to be republished. And this is to make sure that the records there are recent and not stale. So one of the things we'll do is republish your DID document every 2 hours so it could still be discoverable. We'll also include an API that you can use to query different types. This is a feature we've gotten from ION, but it could be used for decentralized discovery. So if you want to advertise yourself as a certain organization, government, or financial institution, which we'll use for TBDEX, you could add this little flag to your record set and allow you to be discovered by these gateway nodes. So now gateways can say, hey, give me all the DIDs you know about that are financial institutions. And if you set that flag, you'll get returned in that set. So it's a good advertising mechanism. Let's see a question. Will these special nodes be able to be best friends with other special nodes? Yes, so that's something we've discussed. We haven't yet implemented it or really spec'd it out, but we're talking about having a network of these special gateway nodes where they're able to discover each other and share retained sets, so you're able to get a more complete view into the network. If you're interested in helping out or have ideas on how that could work, that'd be great for community members to join in on. I'm going to stop talking for now. Oh, actually, one more thing I'll mention. If you've been using DIDs for a while, you've probably heard of 2 methods that are fairly prominent but simple called DID key and DID JWK. They're both kind of similar in that they take a single cryptographic key and create a DID out of it. They don't support updates or deletion or really any other operation besides reading it. And they're not published to a network. They're mostly used for testing, but sometimes in other situations too. And we've talked in the last week, Daniel and I have talked to the authors of both the DID key and DID JWK methods if they're interested in using DHT, and they gave a pretty positive answer and said yes. So what that means is you could extend the capabilities that an existing DID key or DID JWK has by falling back to resolving it from the DHT. So if you don't know about the DHT, you could use it as is. You still have a guarantee that your DID key and DID JWK work. But if you want to check the DHT, you're going to be able to and see if there's additional data associated with these DIDs. So it's an optional extension that could add more utility to these existing DID methods. It's something I haven't specified yet, but I'll be specifying this week, so keep an eye out for updates. And before I stop talking, one more thing. We have implementations already in TypeScript, in Kotlin, and in Go. that are linked in our repo here, which I'll link. And we're also running a server to do this gateway republishing things. And the link for that I'll put here in a second. So we already have a good amount of infrastructure to prove this out. It's already working in a non-production sense. And we're going to keep developing it to make it more robust over the coming weeks and months. Angie said, will this method help with node discovery for TVDEX PFIs? Yes, absolutely. So the type indexing I mentioned earlier, that's how PFIs will be able to advertise. So if you're a PFI, you have a DID, what you're going to do is set this extra flag, add this extra record to say ID equals 7. And then any of these gateways you have access to, you'll be able to query and say, give me all the PFIs, and that's how you'll be able to discover other PFIs that have chosen to advertise themselves. If Daniel's here, he'd want me to mention discovery of these gateways. So how do you find them in the first place? We don't want to restrict or constrain how you discover gateways, but one option Daniel thought of was using Bitcoin to be an advertising mechanism for existing gateways. And we have a section here on registered gateways to do that. The short version is you make a Bitcoin transaction that locks up some funds for a month or so and has an address of your gateway. So this is a way to say, yes, I'm committing some money to prove that I'm a legitimate gateway. And you can now crawl the Bitcoin blockchain, discover this transaction, and discover a gateway. It's an option, and we're going to be probably moving this to a different part of the specification or registry where different types of gateways and discovery for gateways can be done. Why not use did carry? Did carry is very complex and very hard to understand. This is incredibly simple. That is the main reason. I'm also not really sure who is using carry seriously due to its complexity. The main complexity I'm talking about is not having a single anchor point as an option, and their witness system makes it quite tough to determine an absolute state of a DID. And I think it adds in too much optionality to be used in serious use cases. Yeah, I know Glyph uses it, but if you look at Glyph's usage, Glyph is pretty small. Like, they don't have that many users using their VLEIs. Maybe that's growing and maybe that will change, but everyone else I know of that has started to use carry moved away from it due to its complexity. Did I understand correctly that you access DHT like they are DNS servers as well? Yes. So this is more of a Picard goal than a did DHT goal, but the end result of, or ultimate goal of Picard is to replace DNS servers with Picard servers. So they're able to serve signed records instead of just DNS records. Now, we're not really doing anything towards that goal in the near term, but it's something we can consider. An interesting tie-in there is the DID working group in the W3C is going through a rechartering process right now, which that just means they're trying to define their scope of work and what they'll focus on for the next couple of years in the W3C. And one of the things that they're looking to standardize on is DID resolution. And an idea that's been floated by a few of the browser vendors like Google and Mozilla has been, let's find a DID method that we can all implement together to show interoperability. Now, our hope and dream is that DID DHT could be that method because it's not controversial. It doesn't use a blockchain, it uses a DHT, and it's decentralized. It's not static like DID key or DID JWK, and it's not using DNS as a requirement like DID web is using. So that's something that we're going to pursue, proposing this as a standard for all browsers. and with the end goal of having DIDs resolvable just like URLs are resolvable in your browser today. And we think that given the interest from the DID key and DID web, DID key and DID JWK camp already, that it could be an avenue to pursue that would be adopted. Any other questions? Please raise your hand. Feel free to speak in addition to typing.
I have a question, and you might have already answered this, so I'm going to apologize. But my question is this so I know there's a bunch of different DID methods, right? Is this meant to replace DID ion, or did you decide you wanted to create this DID method because there were things with DID ion that just wasn't working for our use case? Like, what made you guys start working on this?
Yeah, so I think there are a few factors. It's a good question. I didn't exactly answer it. The main proponent or supporter of DID ion up until this point has been Microsoft, and we found out that they're moving away from supporting it because none of their customers were really asking for it, and as Matthias mentioned, it was pretty tough to run. So we were running a node, we are running a node ourselves, but we were running into some issues ourselves. So we see DID DHT as a kind of replacement, or better stated, a good default DID method that achieves many of the things, has many of the properties we care about. I don't think this kills Ion in all use cases. Ion still has some features that we're not able to replicate with DHT, namely having a guaranteed universal state because of their use of the Bitcoin blockchain, and guaranteed ordering. There are some pretty niche edge cases here that would be hard to solve. One of them being if someone creates two versions of their DID DHT document and sends them out to different nodes, they could conflict with themselves, and that could be hard to rectify without a guaranteed ordering system like a blockchain. But we don't anticipate those being really big issues because people generally don't want to sabotage their own state. They want to have discoverable keys that allow them to sign and verify messages across the web. So I don't think Ion is dead, but I think this is a good replacement for probably 95 or higher percentage use cases.
Nice, thank you. There was someone. Oh, nice, he's on stage.
Hey, Ender.
If you're speaking, we can't hear you.
Just in the meantime, I want to mention that I've started opening up some issues to help with both the spec development and server development, and could definitely use more input from the community. I haven't yet registered the method with the W3C. We plan on doing that by the end of the week, and also sending out some messages to the community announcing that we're doing this and have already some implementation. So please join in the conversation and help out.
So you said that you haven't registered this with W3C. What is that process like? I'm just curious.
It's pretty simple. They have a registry. DID method.
Hello?
Oh, we can hear you now.
Hey. Oh, okay, got it. Sorry about that. I'll wait till after.
Yeah, so they have this registry, and all you need to do, anyone can do it, is open up a pull request, adding a column for your DID method. Even though they maintain it, they don't have a lot of criteria. They're not very picky about who they include. It's more of an announcement mechanism than anything else.
Oh, nice. Thank you.
All right, Andrew.
Yeah, sorry about that. So what I was saying was actually at IIW, I think it was last year or 2 years ago, and then also you wrote an article about the perfect DID method. I was just wondering if you took ever the DHT and put it to ranks of sort of your criteria for the perfect DID method, and kind of where does it stand in your head? And is there anything that you think, in terms of criteria that you think it could do some work with and improvements?
Yeah, awesome question. So here's the notes from that IAW session. I have 8 criterias.
Also zoom in, please.
Oh, there you
go. Yeah, so let's go through them quickly. Sufficiently decentralized? Yes, it is. Able to scale to billions? Already does. There are billions of torrents out there, and the cost is low. Robust feature set? It doesn't have the ability to do recovery or key rotation, but it meets the others. Able to present a canonical DID state with points in time resolution. With the gateways, this is possible. So I'd say yes. Able to be implemented across multiple permissionless anchor systems. With the DHT, there's only really one anchor system. You could put this on different DHTs, so I wouldn't recommend that. Maybe the anchor system requirement could be interpreted as the discovery of registered gateways, and let's say yes, we're going to do the Bitcoin one, but certainly you could have discovery on Ethereum or other blockchains. Limited complexity. I do think this is pretty straightforward. So I'm going to say yes. Please disagree with me if you do. Memorable and unique names, human readability. We have not achieved this one. And for the reason that the DHT supports ED25519 keys and an encoding of that, which can be hard to make memorable and unique. I kind of moved away from this idea of having names as DIDs because it requires you to have like a one true centralized registry, which I don't think is really desirable because it encourages squatting like domains, and then you have to worry about expiry and takeover and a whole bunch of other complex things. So I've eliminated this as a requirement of a good DID method, even though it would be cool. If Daniel was here, he would mention that you could do something to try to have a vanity domain, which is to repeat a hashing process enough times until you see that your DID starts with some letters or words that you care about. So not exactly memorable and unique, but you could have vanity domains. And the last one, flexible resolution on and offline. You can resolve it offline because the identifier is an encoded key. So the worst case is it falls back to what DID key and DID duplicate do today. And global discovery, yes. So I think we achieve pretty much all of these. Maybe like I'd give it a 6.5 out of 8, but I'm curious what you think, Andrew.
This is helpful. I need to think on it. I'm going to play around a little bit with the tools, but I just wanted to thank you. This is really cool, and I'm excited to test around with it myself. So thanks again, and for clarifying the question.
Sure. All right, question in chat. Where can we find information about the plans of the W3C working group to standardize in DID resolution, DID charter? So a lot of the discussion is going on here. I just put the link in chat. And some is going on in that mailing list. So please keep an eye there. Any other questions, comments? Did that. Yeah, I like that. And we do need t-shirts.
This was really great, Gabe. Does anybody else have any questions? They can also come on stage like Andor did, or you can just keep asking your questions through comments. Was there anything challenging when working on this new DID method? Like, were there any challenges you guys faced?
The toughest thing was documenting the encoding to DNS records. Mm-hmm. We've talked to some folks at the most recent IAW about standardizing this in the IETF. There was some pre-existing work to encode DIDs as DNS records. So it's possible that this will lead to more standards work in IETF, to have this be like a canonical representation of a DID as a DNS packet across DID methods. That was the toughest thing, but I would say we probably haven't run into our toughest problems yet, which only really come with widespread usage and adoption, where we'll run into some real world issues. So please start using it and give us feedback so we can learn more.
Nice. I know earlier you mentioned that I think you created some issues. Do you mind just highlighting a few of them so some members can see like the issues that you have open that people can join in on and help?
Sure. So a lot of them are related to the spec. I've noted that their spec test vectors would be helpful. I'm going to add some today, but as soon as I do that, if you want to add more or test them out in a different language, that would be really useful. Adding registries, if you have different ideas for different registries besides our Bitcoin idea, that would be great. If you know Go or are interested in coding in Go, we have a lot of improvements to the server to make. It's pretty trivial right now, but general server type development like metrics, logging, connecting to other databases. These are all things we could use help with.
Nice. You have 2 questions in the chat.
What kind of performance? Okay, so Picard did some testing. Let's see. They have a benchmarking. And I think they found that it could write up to, they only tested, looks like they might have removed it. They might have removed it, but they tested up to about 100,000 at a time, which is performing pretty well. I don't think we'll know until we get there, but there are billions of torrents out there in the world today. So theoretically, the network should have no problem handling it, but the gateways will be our fallback. So it's kind of as good as we can code our gateways. That's the scale we can get. Let's see. Matthijs, wondering about the special nodes can store all DIDs and how they would know about new DIDs created on the other end of the network. So they don't by default. The solution that we've discussed there, what I mentioned earlier, was adding in a gossip layer. So similar to how Bitcoin nodes learn about other transactions through a mempool, all the nodes are gossiping to one another, which pretty much just means telling their peers what they know about. We could do something similar here, where we add in a gossip protocol so that all the gateways communicate their DID set to one another. That does add some complexity, but it's something we're considering. If anyone has thoughts or experience doing that kind of gossiping, we could definitely use some help. One other point there, there have been some conversations or points raised in the community that knowing about the complete set of DIDs is not desirable because there are existing discovery mechanisms. Like, I don't necessarily know your Twitter handle or your phone number, but I could probably figure it out, whether it's by searching Twitter or Google or somewhere else. And probably the same thing could happen with DIDs. There will be registries or a way to associate individuals or businesses with DIDs that doesn't necessarily need to be solved at the DID method layer. It could just be solved generally for the ecosystem. The second thing is it could be bad for privacy. With ION, you're guaranteed to know all the DIDs that ever existed because they're all written, or a proof of them is written to the blockchain. Here, we don't have that constraint, that property. So you could have some privacy where I could register DID to the DHT and no one else needs to know about it, which maybe is a good thing.
Looks like Angie's typing, so we'll give her a few minutes. But this was a really great presentation, Gabe. I know a lot of people were really interested in like learning more about this method and getting all this insight from you. So thank you for taking the time and doing that with us. Angie's question is, so if Web 5 uses this method by default, will this move us completely off of blockchains?
Yeah, there will never be a requirement to use a blockchain at all. Certainly, if we're going the Bitcoin registered gateway route, that would be a way to discover a gateway, but you using a DID method doesn't require you to use a blockchain at all. I think in TBDEX, we cannot avoid blockchains because that's where the stablecoins or other assets will live. But certainly, if you're building a Web 5 app and using a DID, you won't need to use a blockchain at all.
Nice. Okay, we're going to give it a few more minutes and then we can start wrapping it up. Let's see. Nobody wants to pay for transaction fees. Let's give them a few more moments to type.
Yeah, it's actually cool that the most decentralized network is the one that's existed without a blockchain for the past 15 years. And we found a good way to make use of it, which should be fairly uncontroversial. So that's a big reason we're really excited about this method. Yeah, the IPFS DHT is a good point to raise. There was an issue that was raised here on the car, and I'll put it here for some colorful commentary. The short answer of this long answer is IPFS is pretty slow and not very reliable and hasn't been around as long. Whereas the mainline DHT has millions of nodes, has been around for 15 years, and is very reliable. Yeah, the ability to update. Updates work much like creation does, where you sign over a new set of records, a new data document, and you're able to publish it to any of the gateways. The mainline DHT has this concept of a sequence number, which provides ordering for your documents. And nodes will only accept updates if you've incremented a sequence number. So if you start with 1, the next one has to be greater than 1. So you'd create a sequence number of 2, a new DID document, and then you can update it. The only requirement is that you keep the root key, the one that's used in your DID identifier, the same so that you're able to authenticate that payload. You're able to do any sort of update. And it does have service endpoints. The gateway does not replace it. You're able to have any feature that a DID document can have, you could do with this method. And we have an example here that it does have a service. You could have many. You could have many keys of many different types. The only constraint is that the payload has to be under 1,000 bytes. So something like, 20 different keys or 5 different services is probably about the maximum you could put in there before you start to hit those size limits.
Okay. Gabe, thank you so much. I know it's like my third time saying thank you, but I really appreciate it. I'm sure we all do. Thank you for taking the time. Do you have any like last minute words before we end this event?
No, thanks for coming and asking questions and listening in. Again, please find us on GitHub or ask questions in the Discord. Happy to continue the conversation. And thanks for your interest and thanks for having me speak.